evening all. Good evening to everyone. तो जैसे हम लास्ट 4 क्लास में बहुत कुछ किया है। पहले दिन हम बेसिक्स और रेगुलर एक्सप्रेशंस को कराए और सेकंड डे we have constructed a lot of DFAs and NFAs. We have understood the difference between DFA and NFA. Or third day we have done regular grammars along with some of the conversions like NFA to DFA. और लास्ट क्लास में किया था आइडेंटिफाइंग द लैंग्वेजेस विच आर फाइनाइट, इनफाइनाइट, रेगुलर एंड नॉन रेगुलर्स, है ना। तो अब आपको आइडिया मिला होगा व्हाई वी आर स्टडीइंग थ्योरी ऑफ कंप्यूटेशंस। वी कैन सॉल्व एन नंबर ऑफ प्रॉब्लम्स इन द वर्ल्ड, राइट। बट अब रेगुलर लैंग्वेजेस का जो कॉन्सेप्ट है, जब आपको बिना मेमोरी से सॉल्व कर सकते हैं, जैसे इनपुट दिया है तो एक एक कैरेक्टर को हम रीड करके पूरा स्ट्रिंग को हम रिकग्नाइज कर सकते हैं विच इज बिलोंग्स टू अवर लैंग्वेज और नॉट। लैंग्वेजेस तो बहुत सारे हैं, आपको पता है, एम्प्टी लैंग्वेज और लैंग्वेज विच हैज़ ओनली फाइनाइट नंबर ऑफ स्ट्रिंग्स और लैंग्वेजेस विच हैव इनफाइनाइट नंबर ऑफ स्ट्रिंग्स बट it is regular. So we are able to understand some of the infinite languages and all the finite languages in the world over the sigma, right? Now we have the assume that languages like finite languages, infinite languages, regulars, non-regulars. और इस दुनिया में अगर आपके सामने प्रॉब्लम्स है, कभी कभी ऐसे एक प्रॉब्लम हो सकता, इस प्रॉब्लम बाकी प्रॉब्लम्स के ऊपर भी डिपेंड हो सकता। ऐसा नो, अगर आपको कोई प्रॉब्लम सॉल्व करना है, इट माइट डिपेंड ऑन अदर प्रॉब्लम्स, ऐसा नो। जैसे आपको सर्चिंग करना है एलिमेंट को इन अ गिवन अरे, तो आपको क्या करना होगा, एक कंपैरिजन चाहिए होता whether the given element or given key is there in the array or not। तो एक कंपैरिजन इफ कंडीशन लिखना होगा, राइट। जैसे सॉर्टिंग करना है तो स्वैपिंग की जरूरत पड़ सकता है उसके अंदर। तो एक प्रॉब्लम दूसरी प्रॉब्लम के ऊपर डिपेंड हो सकता। वैसे ही एक क्लोजर प्रॉपर्टीज भी, जैसे आपके सामने बहुत सारे लैंग्वेजेस है और कुछ लैंग्वेजेस लेके और ऑपरेट करके यू कैन फाइंड आउट ए न्यू लैंग्वेज, राइट, है ना। बट ये लेक्चर 5 है क्लोजर प्रॉपर्टीज। और किसी को भी कोई भी डाउट है, सिलेबस कंप्लीट होता नहीं होता, पहले दिन पहले लेक्चर कंप्लीट करके आना और डाउट पूछना। और जो प्रॉमिस किया था वही कर रहा है, और बाकी लोग बीच में आ रहा है जा रहा है तो उनकी मर्जी है। तो जो पढ़ना है नहीं पढ़ना है डिसाइड कर लो। पूरा सिलेबस होता नहीं होता, अब पढ़ के देखना, पूछ के नहीं। मैं कुछ भी बोल देता हूँ बट वीडियो तो गलत नहीं बोलता, राइट। तो वीडियो में जो कंटेंट है आपके सामने दिख रहा है। और लगभग हम कितने घंटे किया था अब तक, 4 दिन में 14 आवर्स, मोर देन 14 आवर्स, लगभग 15 घंटे हम कोर्स कंप्लीट किया, वो सिर्फ 4 दिन में। और ये 5th दिन चल रहा है, तो वो 15 घंटे कंप्लीट करके आना, सिलेबस हो रहा है नहीं हो रहा है तो किसी से दुनिया में पूछना जरूरत नहीं, वीडियो में ऑलरेडी प्रूफ है जो हम कर रहा है, राइट। और इस क्लोजर प्रॉपर्टीज में ऑफ कोर्स एनीबॉडी इज न्यू दिस डे, राइट, जस्ट नो अबाउट मी। एंड देन अगर किसी को भी नहीं पता लेक्चर कहाँ मिलता है, PDF फॉर्म में, तो इस URL में जाके ड्राइव है, गूगल ड्राइव का लिंक है, तो वहाँ जाके आप डाउनलोड कर लीजिए। बाकी प्रीवियस लेक्चर्स भी वहाँ मिला है, वहाँ है, ठीक है। और चालू करते क्लोजर प्रॉपर्टीज। और क्लोजर प्रॉपर्टीज का मतलब क्या है? देखो, दुनिया में बहुत सारे ऑपरेशंस है, ऐसा नो, कितने ऑपरेशंस होगा दुनिया में, राइट। यू कैन क्रिएट even your own operation depending on the previous operations, right? You can create a new problem by depending on the previous problems। ऐसे ही यहाँ भी प्रॉपर्टीज बहुत है दुनिया में, और इंपॉर्टेंट प्रॉपर्टीज को हम कवर करेंगे जो एग्जाम में पूछा जाता है अंडर ग्रेजुएट लेवल में, राइट। अगर मैं इसी को पढ़ाऊँ तो ये 1 महीने तक क्लोजर प्रॉपर्टीज ही चलेगा कि यू कैन क्रिएट ना ऑपरेशंस है दुनिया में, यू कैन मेक योर ओन ऑपरेशंस टू। तो क्लोजर प्रॉपर्टीज यू कैन अप्लाई। यहां पर क्लोजर प्रॉपर्टीज को समझने के लिए 2 पॉइंट्स चाहिए होता, एक जो है डोमेन और किस लैंग्वेजेस को अप्लाई करने वाला है, और दूसरा ऑपरेशन। दिस ऑपरेशन is going to define lot of operations like I'll talk about. ये दो चीजें आपको पढ़ना होगा, डोमेन एंड ऑपरेशंस। और क्या क्या डोमेन हो सकता दुनिया में अब जो किया है, राइट। मैथमेटिक्स में तो बहुत सारे डोमेन्स है, नेचुरल सेट, इंटीजर सेट, रियल सेट, इवन सेट, ऑड सेट, प्राइम सेट, ऐसे दुनिया भर के आपको सेट्स मिलेगा, इनफिनिट सेट्स एज वेल एज फाइनाइट सेट्स। यहाँ पर भी हम लैंग्वेजेस को अप्लाई करने वाला है, हम अप्लाई करने वाला है डोमेन्स, सेट ऑफ और क्लास ऑफ फाइनाइट लैंग्वेजेस और फाइनाइट सेट्स, ये फाइनाइट लैंग्वेजेस के लिए अप्लाई करने के लिए। और सेट ऑफ इनफिनिट लैंग्वेजेस कैन कॉल इनफिनिट सेट्स, और सेट ऑफ regular languages, so you can call regular sets over the sigma, set of non-regular sets. You can also apply set of context free languages, वो तो अभी नहीं किया, तो फ्यूचर में हम अब करने वाला है, और set of CFLs। ऐसे कितने सारे लैंग्वेजेस है, बहुत सारे डिफरेंट डोमेन्स है, बहुत सारे डोमेन्स है। और ऑपरेशंस क्या हो सकता, यूनियन, दो लैंग्वेजेस के बीच में ये बाइनरी ऑपरेशन है, इंटरसेक्शन, सेट डिफरेंस, कंकैटिनेशन और कॉम्प्लीमेंट, ऐसे बहुत सारे ऑपरेशंस इधर भी है। तो ये जो पर्टिकुलर डोमेन दिया है, तो यू कैन अप्लाई ऑल द ऑपरेशंस हियर। कुछ ऑपरेशंस ऐसे होता है क्लोज होता है, कुछ ऑपरेशंस नॉट क्लोज होता है। तो आपको ये फाइंड आउट करना होगा, ये एग्जाम में दिया होगा, इज दैट यूनियन क्लोज्ड फॉर फाइनाइट लैंग्वेजेस और नॉट। तो आपको डोमेन फिक्स करना होगा, इस यूनियन को यहाँ अप्लाई करना होगा। तो कैसे अप्लाई करेंगे, वही ये टॉपिक है क्लोजर प्रॉपर्टीज, ठीक है। तो हम पढ़ने वाला है क्लोज्ड और नॉट क्लोज्ड टू डेफिनेशन। सबसे पहले इस डोमेन को, यार ये ले सकते ना, ये डोमेन को डी मान लो, मतलब ये D1 है, ये D2 है, और ऐसे बहुत सारे डोमेन्स है, इनफिनिट डोमेन्स यू कैन क्रिएट आप डिपेंडिंग ऑन योर रिक्वायरमेंट। ये ऑपरेशंस है, मान लो ये वो है, ये वो 1, O2, O3, O4, देयर आर इनफिनिट ऑपरेशंस, करेक्ट। अब ऐसे कर लेते हैं हम, एक डोमेन एक ऑपरेशन लेके डेफिनेशन हम पढ़ने वाला है। देयर आर 2 काइंड्स ऑफ डेफिनेशंस, एक जो है क्लोज्ड वाला, एक नॉट क्लोज्ड। डी कामा वो मीन्स ऑपरेशन, इज क्लोज्ड। एक और है, डोमेन भी दिया है, ऑपरेशन भी दिया है, इज इट क्लोज्ड और नॉट क्लोज्ड हम पढ़ने वाला है। अगर नॉट क्लोज्ड है क्या होगा डेफिनेशन, राइट। इनका मतलब क्या होता है, दिस ऑपरेशन इज क्लोज्ड अंडर फॉर दिस डोमेन एंड दिस ऑपरेशन इज नॉट क्लोज्ड फॉर दिस डोमेन। अदरवाइज डोमेन इज क्लोज्ड अंडर दिस ऑपरेशन, दिस डोमेन इज नॉट क्लोज्ड अंडर दिस ऑपरेशन। वी कैन स्पीक। तो ये कब होगा क्लोज्ड, ये कब होगा नॉट क्लोज्ड। फॉर ऑल लैंग्वेजेस, जितने भी इसमें लैंग्वेजेस है सेम और डिफरेंट, 2 लैंग्वेजेस लेना डोमेन से, आप अप्लाई करना ऑपरेशन, तो बाइनरी ऑपरेशन के लिए। यूनरी होगा तो एक ही लैंग्वेज लेना, सच दैट ऑपरेशन अगर बाइनरी है 2 ऑपरेंड्स होना चाहिए, अगर यूनरी है एक ही ऑपरेशन है। तो अगर कॉम्प्लीमेंट अप्लाई करने वाला है एक ही लैंग्वेज को अप्लाई करोगे कॉम्प्लीमेंट, अगर यूनियन अप्लाई करना है 2, इंटरसेक्शन 2 लैंग्वेजेस, डिफरेंस 2 लैंग्वेजेस, कंकैटिनेशन 2 लैंग्वेजेस, अगर क्लीन स्टार अप्लाई करना है एक ही लैंग्वेज के ऊपर, सबसेट अप्लाई करना है एक ही लैंग्वेज के ऊपर। तो ऑपरेशन डिसाइड करेगा ये 2 लैंग्वेजेस लेना है, 1 लैंग्वेज लेना है, और 100 लैंग्वेजेस लेना है एट ए टाइम। तो ऑपरेशन डिसाइड्स। आपको पता है operations again, unary, binary, ternary, k-array, right, 4-array, 5-array, you can apply to any number of the operands, depends on the operation type. Even in theoretically we are also going to study even infinite inputs also you can apply the operation, जैसे infinite union, infinite intersection, or finite union, finite intersection is going to be k-array operator, राइट, अभी तो चालू हो रहा है। और दो लैंग्वेजेस डोमेन से लेना, और ये एक सिर्फ सम टू लैंग्वेजेस नहीं, एवरी टू लैंग्वेजेस, ये दोनों सेम है और डिफरेंट चल जाता, और ये डोमेन के अंदर होना चाहिए, और ऑपरेशन अप्लाई करने के बाद भी वो डोमेन के अंदर है, एंड वो भी फॉर एवरी टू लैंग्वेजेस के लिए, देन वी से इट इज क्लोज्ड। एग्जांपल बता रहा हूं, सपोज डी इज गिवन सेट ऑफ ऑल फाइनाइट लैंग्वेजेस, दिस ऑल लिखना जरूरत नहीं है, सेट ऑफ फाइनाइट लैंग्वेजेस और सेट ऑफ फाइनाइट सेट्स ओवर द सिग्मा, और ऑपरेशन लेट्स से यूनियन। अब बताओ ये जो सेट ऑफ ऑल फाइनाइट सेट्स, इज इट क्लोज्ड अंडर यूनियन ऑपरेशन और नॉट? जो भी फाइनाइट लैंग्वेजेस लेना, दो फाइनाइट लैंग्वेजेस को पिक करो और यूनियन करना, रिजल्ट फाइनाइट आएगा नहीं आएगा? अगर फाइनाइट आया, हमेशा फाइनाइट आया, देन वी कैन से दैट दिस सेट ऑफ फाइनाइट लैंग्वेजेस क्लोज्ड अंडर यूनियन ऑपरेशन। अभी बताओ क्या है? Yes, finite union and infinite union is different. Finite union means take the finite number of operands. Infinite union means take the infinite number of operands. ठीक, वो भी हम देखने वाले slowly. Can I say it is closed or not? Because every two finite languages, you can take F1, F2, these are two languages, apply the union, the result is always finite after doing the union. Two finite languages union is always finite, no matter which finite language you take in the world. This is what the definition of closed. Closed means you will always get inside the domain. Getting? But domain is very important. Are you applying for finite languages? Take only finite. Are you applying for infinite languages? Take only infinite. If you take different languages, then we can't talk about closed word. Okay. Now come to this not closed. Not closed prove करना है, तो आप हमेशा जरूरत नहीं, अगर एक एग्जाम्पल भी फाइंड आउट किया, एक एग्जाम्पल L1, L2 belongs to D, सम L1, L2 वो दोनों सेम है, अलग है, आपकी चॉइस है, और जब अप्लाई किया उनकी रिजल्ट जो है वो डी के अंदर नहीं है। आप डी से तो लिया है बट रिजल्ट डी के अंदर नहीं आ रहा है, तो ऐसे कोई भी एक एग्जांपल है तो इट्स ओवर, इट इज नॉट क्लोज्ड। इवन दो everybody is inside domain, even one example also you found which is not in domain, it is not closed, है ना? Example, can you find example? Let's take we are applying for infinite languages. I'm applying O means intersection. अब बताओ, टू इन्फिनाइट लैंग्वेजेस लिया, क्यों डोमेन के अंदर इन्फिनाइट लैंग्वेजेस है, टू इन्फिनाइट लैंग्वेजेस पिक किया, इंटरसेक्शन किया, इन्फिनाइट आएगा और नहीं आएगा, may or may not be, बिल्कुल। That means, do you find this answer? There are two infinite languages in the domain, their result is not in the domain. Can you find that? Inside I don't want. Is there any example which goes outside the domain? Just write I1, let's say infinite language, I2 is another infinite language, and when you apply intersection, the result is may or may not be infinite. Bilkul right. Do you have any example? There are some two infinite languages, the result is not infinite after doing intersection. Okay, for that I will give an example. You can see here. Only example is sufficient. L1 is equal to A star, L2 is equal to B star. Both are infinite. I1 and I2 you can assume. And after applying intersection, you get only epsilon is a common. This is not infinite, means it is a finite here. You got outside the domain. This both are belongs to D, but this is not belongs to D because not infinite. So you got this example, so that's why the intersection is not closed for infinite languages. Also understand, not closed doesn't mean that not infinite. Remember that. At least one example you will find that is not infinite. So that point you have to remember. Many people misunderstand not closed. Correct? There is another word is, some people say may not be closed. There is no such word in the world, may not be closed. definition, either closed or not closed. Okay, closed means always in the domain, not closed means some example is there which goes outside domain after applying the operation. You know? Done? All definitions clear? Two definitions. Without these two definitions, please don't study closure properties. And anybody not understood, first focus and try to understand what is closed, what is not closed. And also in discrete mathematics, there is a topic called as group theory. The whole group theory is going to begin with the closure definition. The same definition was used in the group theory. The first point, closure, binary operation. The definition of the binary operation closure depends on the same, right? For every two elements in the domain, if you apply the operation, result has to be in the domain. The same definition is applied. Here we take the languages, there we take elements. Okay. Are we ready to start the closure properties? First we'll apply for finite languages. Once you got a clarity, because finite language you can think like a mathematics, right? COC knowledge may not be required to understand the finite sets, but still you try to understand first finite languages. So our domain, I'm applying D is class of or set of finite languages. So I'm applying for finite languages over the sigma. Any sigma you can take. And O is O that we are going to find out. There are a lot of O's we can, right? We are applying for finite languages, closure properties for finite languages. That is the heading now. Okay. Closure properties for finite languages. That means operations we are applying for finite languages. They may not mention the D, but here this line has a D. You are going to apply various operations for finite languages. So you need to understand D is given as the finite languages. String is different, language is different. It's not a string, it is a language, okay? String operations are different from language operations. Everybody? Here you need to focus on the language, not on the string. Union we apply for the language, not for the strings. You pick the languages, not strings, right? That's a different closure property. Closure properties, when you apply for one language, you pick the strings. But are you applying for one language for all the languages? The two words are different. Closure properties, a property for a language. This is different word. Closure properties for languages. Completely different line. When you are applying for languages, you pick the languages. When you apply for a language, you pick the strings if the language has strings, right? So both are different concepts. And first we are learning for languages. If you want to apply for one language, then inside the language strings are there. You need to take the strings. The operations will become the string operations. Now we are not applying for string operations. Here string operations are applicable because language has strings. And here we are applying for set operations, language operations. So both are different. Here we apply string operations if that language has the strings. Here we apply language operations, also called as set operations. For this point, so understand the closure property can be applied even for mathematical sets and even for the strings, even for the languages, even for the some other programs, even for something else. Okay, even for matrices you can apply closure properties. Okay, easy operation is union. You tell me whether it is closed or not. Intersection. One example already given for you, right? When I put the 3 stars, please revise multiple times. Also called as relative complementary difference. that difference. There are many operations we'll study in regular languages. Okay, just we'll study now only for 6 operations. Go ahead. Is it closed or not closed? What is your domain? Domain is fixed, finite languages, right? How to apply and whether it's closed or not. Look at how to apply. And answer it closed or not closed. First thing is you should learn how to apply it. So you need to work on 2 finite languages. So finite language without knowing which language it is, right? Finite language 1, union, finite. Every 2 finite languages you have to think. My question is the result always finite or not? That we need to work out. How to apply? So take the finite language and take a finite language. These 2 may be same or different, I don't know. But you should think about every 2 finite language in the domain. Will you get always finite? Is there any case you will not get a finite? Do you have any example the result is not a finite? I pick the finite, do the union. Will you get a finite or not? Union is always finite no matter which finite languages you take. Result is always finite no matter which finite, right? Always what no need to write, because when I write finite it is always only. So that is the reason we say it is closed, correct? If you don't get always finite, will you say closed? We can't say it. Okay, this is must to say the closed. If this is not happening, always is not in the domain, then doesn't matter it is going always outside the domain or sometimes it is not closed only. Okay, next one, intersection. Finite intersection, I'll write in a short form. Finite 1 intersection finite language 2. What is the result? Is it always finite? Yes, always finite. Right, always. No need to write that word always. Can we say closed? Yes. And can you tell me the finite language? You take a finite language, do the complement, what will be the result? Will you get finite or infinite? Anyone? Or will you get sometimes not finite or every time not finite? What is the answer? Finite language complement. So 1 point, that's why I kept the 3 star. I don't know how many of you understood this. First, look at any language you do the complement, the answer is sigma star minus L. Yes or no? This point is very, very important to do the complement of a language over the sigma. Doesn't matter which language you take over the sigma, this is the definition of a complement. That's why when you take L is equal to the sigma star, the L complement will be pi. If you take L is equal to epsilon, then L complement will be sigma plus. Because when you do the union, you should get everything. When you do the intersection, you get nothing. Right? Ab finite language You take a complement. Is it sigma star minus finite language? This is already infinite. From the infinite, you delete the finite. Is it always infinite or not? Always. That means it's a not finite. Are you able to understand? You get an infinite language always. That means always you are going outside the domain. Even at least one time you go outside the domain, it's not closed, right? Are you able to understand this point? Finite language complement, you always get infinite because from the sigma star you are deleting the finite language. Keep this in mind and don't misunderstand this point, because in mathematics we do universal set. Here universal set is a sigma star. But in mathematics universal set can be finite or infinite. But in TOC universal set is always infinite because the sigma star is infinite here. Okay, mathematics and TOC, there is a difference in the universal set. So in a mathematical universal set, the universal set can be finite, but here universal language is always infinite because we do sigma star. Okay, keep that in mind. Now, finite language complement is not always not finite. When we want some time, it is not closed, right? But always not inside the domain. Okay, so we don't need always, but sometimes not finite is also not closed. Even always, correct? Also not closed. And it's a very interesting example. Just we need one example in the world. Finite complement is not finite, but we have everyone as example. Every finite language is the reason why it is not closed. You wanted to find some finite language whose complement is not inside, but you get everybody as the reason. Now difference. How to apply? That is a very important concept. Finite 1 minus finite 2. What is the result? From the finite language, delete anything. This has to be finite, right? The finite language, you are deleting another finite concept. So this has to be finite only because you're not adding it, you are removing it. Result is always finite. That always word is not compulsory, but if you wanted to understand, you can write the complete answer. Always finite. Always finite, always inside the domain is representing closed only. And concatenation. Take two finite languages because the binary operation. Finite language, do the concatenation with another finite language. Will you get the finite only? Always finite. Closed or not closed? Now reversal. Take any finite language, do the reversal. Means go to every string and do the reverse. So you will get a language reversal. Take the finite language, apply the reversal. What happens? Result is always finite. So this is also closed. Are you able to understand closed, not closed? By definition, not by math. By definition, of course, everything is mathematical concept. Using that definition. Take any example, right? Apply it. You will get the same answer or not. Some operations you may get sometimes inside the domain, sometimes outside the domain. Example, Kleene Star. I did not apply it, but if you want to apply Kleene Star for a finite language, take empty language. When you apply the Kleene Star, you will get epsilon. Pi star is epsilon, right? So again you got a finite language. Take epsilon, is a finite language. That language has only epsilon. Take Kleene Star, you will get again the same language. That is also finite. But when you take any other finite language, the Kleene Star will become infinite. So if you want to apply the another note I am keeping here, Kleene Star. If you want to apply on finite language, if you apply the Kleene Star, the result can be, need not be finite. Sometimes finite, sometimes infinite. And to understand this example, आपको ये पता होना चाहिए which finite. Some examples, case 1, if I take the language is equal to pi, the L star is epsilon. Some languages like epsilon, if you apply L star, is also epsilon. But if you take, let's say any finite language, let me take A, L star is infinite. And you take any other language, like if I take only finite language I am taking, let's take A comma AB, and L star is again infinite. This all are finite languages, but result sometimes finite, sometimes infinite, correct? This is the finite language only what we have taken. But result is sometimes finite or infinite result. That's the reason the Kleene star for finite language is not closed. Right. Sometimes finite, sometimes infinite. I did not apply in the same list, but you can try for any other operations like this. But understand what happens when you take the finite languages and apply the operation, what happens to the result. If it is always in the domain, then that is closed. Even one time you go outside the domain, it is not closed. Okay. When it is closed, always inside the domain. When it is not closed, at least one time it goes outside. That at least one time, maybe all the time or sometimes. Now, the same kind of the list can you apply for infinite languages? I'll leave to you now. The domain we are taking for instead of infinite, we take instead of finite, we'll take infinite. Can you apply? Tell me what is the result? Or better. Okay, find out. You already know what to do. Just let me know the answers. For these operations, you apply for the domain infinite languages. अगर आप infinite languages को apply किया, क्या होता है result? Let's see. Again, complement is really important for you. मैं डायरेक्टली बताता हूं क्या आंसर है. यूनियन क्लोज्ड. आप रीजन फाइंड आउट करना व्हाई इट इज क्लोज्ड. इंटरसेक्शन नॉट क्लोज्ड. कॉम्प्लीमेंट नॉट क्लोज्ड. कोई भी क्लोज्ड नॉट क्लोज्ड में कंफ्यूजन है तो फाइंड आउट दिस कॉलम विल हेल्प यू. Infinite minus infinite not closed, could be anything. Concatenation closed. Infinite followed by infinite is always infinite. Reversal is closed. If you don't understand any statement, let me know. है ना? Infinite language union, infinite language, what is the result? always infinite, need not be infinite. Just you can take A star intersection B star. You have seen epsilon was a common. That is the finite, not infinite, right? So sometimes infinite, sometimes not infinite. If you want infinite, take the same A star intersection A star, you'll get A star. So proving infinite is, you have a lot of examples, but proving not infinite, you need to look at carefully. Complement of infinite, अगर आप सिग्मा स्टार लिया, उनकी कॉम्प्लीमेंट तो एम्प्टी लैंग्वेज है, इन्फिनिट लैंग्वेज का कॉम्प्लीमेंट फाइनाइट भी हो सकता. अगर स्टार्टिंग विथ ए स्ट्रिंग्स लिया तो उनकी कॉम्प्लीमेंट स्टार्टिंग विथ बी यूनियन एप्सिलॉन होता, तो दोनों इन्फिनिट है, तो ये भी रिजल्ट नीड नॉट बी इन्फिनिट आएगा. इन्फिनिट माइनस इन्फिनिट, अगर सेम लैंग्वेज को ए स्टार माइनस ए स्टार किया, एम्प्टी लैंग्वेज आएगा, राइट. अगर ए स्टार माइनस कोई बी स्टार लिया तो ए प्लस आएगा, तो कभी कभी फाइनाइट कभी कभी इन्फिनिट. Infinite dot infinite, always infinite, always. Infinite reversal, always infinite. Right? Yes. Now you can't remember, you have to understand. When there are many things are coming into the picture, आपको समझना होगा कि इसको याद रखना impossible. Of course possible only for they practice lot to remember. We don't practice to remember, we practice to understand. ताकि आपका जो भी ऑपरेशन आएगा कैसे अप्लाई करना है वो पता है, तो आंसर भी पता होगा. सिर्फ वो जो याद रखेगा वो भूल जाएगा, बट ये समझ में आएगा उनको, ये प्रूव करना इजी होता. इज इट क्लियर? ये कॉलम आपको समझना होगा. व्हाई द ऑपरेशंस आर क्लोज नॉट क्लोज्ड, ये रीजन है. तो इसलिए बहुत लोग को याद रखना जरूरत नहीं पड़ता, कि उनको पता है वो कैसे प्रूव करना है. करेक्ट? तो आपको भी अगर आज तक सिर्फ याद रख के जा रहा है, कोई पढ़ा रहा है आपको सिर्फ क्लोज नॉट क्लोज्ड, बट नहीं बता पा रहा है क्यों नॉट क्लोज्ड क्लोज्ड, तो ये आपको प्रैक्टिस करना होगा. और एग्जाम्पल के साथ प्रैक्टिस करो, क्यों आप क्रैश कोर्स में ज्यादा एग्जाम्पल नहीं ले सकते, तो इसलिए मैं डायरेक्टली फाइनाइट इनफिनिट में पॉइंट पे आया, बट रेगुलर लैंग्वेज में हम बहुत ज्यादा प्रैक्टिस करेंगे. तो अभी इनफिनिट इंटरसेक्शन इनफिनिट तो एग्जाम्पल दिया ना, या एक ए स्टार लिया और इंटरसेक्शन बी स्टार, रिजल्ट क्या आया? एप्सिलॉन. अगर दोनों सेम लिया, ए स्टार इंटरसेक्शन ए स्टार, रिजल्ट ए स्टार. देखा, कभी कभी फाइनाइट कभी कभी इनफिनिट, इसलिए आंसर लिखा नीड नॉट बी इनफिनिट. और कॉम्प्लीमेंट के लिए भी वैसे है, सिग्मा स्टार की कॉम्प्लीमेंट लिया पाई आएगा, स्टार्टिंग विथ ए का कॉम्प्लीमेंट लिया स्टार्टिंग विथ बी यूनियन एप्सिलॉन, तो दोनों इनफिनिट है. तो हम एग्जांपल्स को प्रैक्टिस करेंगे बट रेगुलर लैंग्वेज के साथ. Are we ready to start the regular languages? अगर क्लीन स्टार इन्फिनिट लैंग्वेजेस के लिए अप्लाई किया, इन्फिनिट ही आएगा, तो वो भी आप प्रैक्टिस कर सकते हैं इधर. फाइनाइट लैंग्वेज के लिए हमेशा सॉरी समटाइम्स फाइनाइट समटाइम्स इन्फिनिट. अगर यही कॉन्सेप्ट आप इन्फिनिट लैंग्वेज के लिए अप्लाई किया तो क्या होता रिजल्ट? ऑलवेज इन्फिनिट. कोई भी इन्फिनिट लैंग्वेज लेके आप रिपीट कर दो, Kleene Star, right? 0 or more times, the result union of all of them will give infinite only. Right. सब नहीं आएगा, एक दो एग्जाम्पल से तो आपको प्रैक्टिस करना होगा. रेगुलर लैंग्वेज में यू कैन प्रूव इट विथ अ फ्यू एग्जाम्पल्स. आपको रेगुलर लैंग्वेज में प्रूव करना है तो याद रखना कुछ एग्जाम्पल्स, लाइक एम्प्टी लैंग्वेज आपको पता है, सिग्मा स्टार आपको पता है ये रेगुलर है, और ए पावर एन बी पावर एन ये नॉन रेगुलर है, और इनकी कॉम्प्लीमेंट भी नॉन रेगुलर है. तो ये याद रखना ताकि बहुत सारे प्रूव कर सकते हैं आप. ये नॉट रेगुलर है, ये रेगुलर है. व्हाट इट? वो तो काउंटेबल लैंग्वेजेस, दिस डिफरेंट डेफिनेशन, डिफरेंट टॉपिक। काउंटेबिलिटी, द डिसाइडेबिलिटी अनडिसाइडेबिलिटी के बाद वो आप ट्राई कर सकते हैं। अभी काउंटेबिलिटी की मतलब नहीं होता, दैट शुड बी द लास्ट टॉपिक इन द टीओसी। कि पूरा लैंग्वेजेस को समझने के बाद आप काउंटेबल लैंग्वेजेस में जाना तो इजी रहेगा। अभी सेंसलेस, मीनिंगलेस होता है, सब कॉन्सेप्ट ही नहीं पता, आप काउंटेबल लैंग्वेज में जाके पढ़ रहे हैं तो आपको समझ नहीं आता किस लैंग्वेजेस के बारे में बात कर रहा है। That's why DCFL, CFL, CSL, REL, डिसाइडेबल, ये लैंग्वेज का नाम ही यूज नहीं कर रहा हूं मैं। सिर्फ रेगुलर, रेगुलर में फाइनाइट इनफाइनाइट दोनों आता है इसलिए फाइनाइट इनफाइनाइट लिया, और नॉन रेगुलर भी यूज कर रहा हूँ क्योंकि नॉन रेगुलर ऑलरेडी पता है, लास्ट क्लास में किया है। इंपॉर्टेंट तो है, कितना इंपॉर्टेंट है वो डिपेंड्स ऑन दी टॉपिक। तो काउंटेबिलिटी उतना नहीं आया, कभी कभी आया, 2 बार तो आया शायद, तो आया मतलब आएगा, पढ़ना ही पड़ेगा आपको। इतना इंपॉर्टेंट कोई बता नहीं सकते, बट विच टॉपिक्स आर इंपॉर्टेंट विच आर कमिंग रेगुलर दैट यू कैन थिंक अबाउट। क्लोजर प्रॉपर्टीज बहुत इंपॉर्टेंट है, तो एटलीस्ट 1 क्वेश्चन एवरी ईयर कम्स आइदर यूजिंग रेगुलर्स और यूजिंग CFLs, ये 2 में। ठीक, अगर फाइनाइट इनफाइनाइट आया तो वैसे भी वो दोनों में कवर होता है। ये सबको पता है रेगुलर्स क्या है, नॉट रेगुलर्स क्या है। अगर फ्यूचर में कोई भी प्रॉपर्टी आपको प्रूव करना है, मैक्सिमम आप इस 4 लैंग्वेज लेके प्रूव कर सकते हैं। गॉट इट? वही पढ़ा रहा हूं, क्लोजर प्रॉपर्टीज। ठीक, क्लोजर प्रॉपर्टीज फॉर रेगुलर लैंग्वेजेस, ये है ना। ये लिस्ट याद नहीं रख सकते होंगे, बट कोई भी ऑपरेशन आया तो उनका डेफिनेशन याद रखना चाहिए आपको। अगर समझ लिया तो डेफिनेशन तो अप्लाई करोगे। तो इसमें क्या, नॉट क्लोज याद रखो, तो क्लोज तो ऑटोमेटिकली आपको मिल जाएगा। कैन यू फाइंड आउट, आपको जो पता है रेगुलर लैंग्वेजेस के बारे में यूज करके, कैन यू फाइंड आउट द आंसर। अगर आपको पता है विच इज नॉट क्लोज्ड, बस जो जो ऑपरेशंस नॉट क्लोज्ड है उनका नाम बता देना. यू नो एनी ऑफ दिस ऑपरेशंस नॉट क्लोज्ड, प्लीज लिस्ट आउट इन द चैट बॉक्स. तब तक मैं ऑपरेशंस का सारे नाम लिख दूंगा. एग्जाम में सिर्फ 5 सेकंड लगेगा विच इज क्लोज्ड और नॉट क्लोज्ड बताने के लिए. बहुत इजी शॉर्टकट है, मैं ही नहीं बताता हूँ, ये मैं इन्वेंट किया, बट इसके पीछे बहुत प्रैक्टिस है, बहुत एनालिसिस है. तो सिर्फ 2 लेटर से पूरा लिस्ट याद रख सकते हैं आप. सबसे पहले ईच ऑपरेशन को पढ़ना है, वो क्या है. जैसे ईच ऑपरेशन समझ में आया, देन यू कैन गो फॉर अप्लाइंग. डायरेक्टली अप्लाई करना नहीं होता. क्यों? सबसे पहले ऑपरेशन का डेफिनेशन. ये तो काफी इजी है कि ऑलरेडी फाइनाइट इनफाइनाइट में अप्लाई किया होगा, बट बाकी जो है यू नीड टू प्रैक्टिस फर्स्ट व्हाट इज द डेफिनेशन. कोई इंपॉर्टेंट ऑपरेशन भूल गए इसमें. ठीक, काफी है. लिस्ट सेपरेटली याद रखना पड़ेगा आपको. 21 स्पेशल ऑपरेशन है आपके लिए. फाइनेट यूनियन. 22 फाइनेट इंटरसेक्शन. एग्जाम में आया भी है. फाइनेट डिफरेंस. बताइए क्या आपको कुछ आंसर मिला तक? जो लिस्ट बनाया इधर, एक एक ऑपरेशन पे फोकस रखना. राइट। तो यहाँ पर आपको ये ऑपरेशन याद रखना होगा, जो रेड कलर में दिख रहा है बिल्कुल वही याद रखना होगा। Done? क्या सोच रहे हैं आप? ये सारे क्या है? टिक मतलब याद रखना क्लोज्ड। इसमें सारे ऑपरेशंस एक्सेप्ट जो रेड कलर में दिख रहा है वो क्या है? दे आर क्लोज्ड। मतलब कितना इजी है याद रखना, क्लोज नॉट क्लोज्ड। बट कोई एग्जाम्पल दिया है तो उनको आंसर करना इजी नहीं, क्यों? उसको समझना होगा आपको आंसर करना है तो। बाकी ये जो दिख रहा है रेड कलर का सारे नॉट क्लोज्ड। करेक्ट। इसको सिर्फ इतना याद रख सकते, एस आई ऑल, बस 2 लेटर से पूरा कॉन्सेप्ट क्लियर है। एस मतलब याद रखना सबसेट, एंड आई मतलब इनफिनिट फॉलोड बाय एनी ऑपरेशन। आई ऑल मतलब इनफिनिट फॉलोड बाय जो भी ऑपरेशन दिया है, ये दोनों नॉट क्लोज्ड है, बाकी सारे क्लोज्ड है। आर यू एबल टू अंडरस्टैंड? तो इसको याद रखना इजी है। नो, ऑर्डर डजंट इज नॉट इंपॉर्टेंट, कोई भी ऑर्डर लिख सकते, बट उसमें से सबसेट फॉलोड बाय इनफिनिट, सबसेट एंड इनफिनिट फॉलोड बाय एनी ऑपरेशन इज नॉट क्लोज्ड। जो रेगुलर गारंटी नहीं होता इसमें रिजल्ट। सबसेट ऑफ रेगुलर need not be regular. Infinite union when you apply for regular need not be regular. Similarly remaining. Can we start one by one? यहाँ पर खास बात क्या है? You need to understand each operation, why it is closed, why it is not closed. एग्जाम में एग्जाम्पल भी आ सकता, और 3 टाइप क्वेश्चंस होगा। कितने टाइप? 3 टाइप। एक जो है क्लोज्ड और नॉट क्लोज्ड। सेकंड जो है तो इन जनरल रेगुलर यूनियन रेगुलर पूछेगा, वो रिजल्ट क्या है, तो आपको रेगुलर बताना होगा, क्लोज नहीं बताना। रेगुलर यूनियन रेगुलर मीन्स रेगुलर, और व्हेन यू अप्लाई यूनियन फॉर रेगुलर इट इज क्लोज्ड। एंड थर्ड टाइप इज एग्जाम्पल। तो 3 टाइप्स ऑफ क्वेश्चंस यहां पर रहेगा, वो हम स्टार्ट करेंगे यूनियन से। अभी रेडी? रेड कलर पार्ट इज नॉट क्लोज्ड, बिल्कुल। फाइनाइट यूनियन इज क्लोज्ड, वही तो कह रहा है। यूनियन क्लोज्ड होगा तो फाइनाइट यूनियन क्लोज होगा ना। इनफाइनाइट यूनियन इज नॉट क्लोज्ड, नॉट अ फाइनाइट। ओके, चलिए। कितने वेराइटी ऑफ क्वेश्चंस आ सकता सिर्फ व्हेन यू अप्लाइंग फॉर यूनियन फॉर रेगुलर लैंग्वेजेस? इज इट क्लोज्ड और नॉट क्लोज्ड? इज इट क्लोज्ड और नॉट क्लोज्ड? जल्दी बताइए। क्लोज्ड। तो नॉट क्लोज्ड होता तो एग्जाम्पल क्लोज होगा तो प्रूफ बाय एल्गोरिथम। तो इनको एल्गोरिथम देना होगा, एग्जाम्पल से काम नहीं होता। कभी भी क्लोज्ड होता, यू नीड एन एल्गोरिथम टू प्रूव फॉर एनी रेगुलर लैंग्वेजेस, यू नीड टू प्रूव इट इज द रिजल्ट इज रेगुलर, है ना? तो अगर कोई भी एग्जाम्पल दिया, ये तो एक क्वेश्चन हो गया, राइट? और दूसरा क्वेश्चन जो है regular language union another regular language, or same or another, doesn't matter. Result, what is it? Regular union regular. What do you say? Now don't say closed word. Closed is for when the domain is given, operation is given. Now you have given that regular union regular. The result you need to talk about. Is it always regular or sometimes regular? What is the result? Result is always regular. And what is the proof? वो तो अलग ही बात है. तो प्रूफ यही बताएगा why it is closed. अगर कोई बता रहा है L1 is regular and L2 is regular, how to prove that L1 union L2 is regular? Anyone? Very simple proof क्या है? दोनों के लिए रेगुलर एक्सप्रेशन बना लो. Right? How to prove it? Take them, write regular expression for L1, assume it is R1. Write regular expression for L2, assume it is R2. Now, can we write regular expression for union? If you can write it, you have proved it is regular already. It is R1 plus R2. This regular expression will work for the union. So union के लिए भी regular expression है. इसका मतलब union is regular always. Another proof is you can design a DFA. There is an algorithm called as compound finite automata. In semester you might study, and here we have already studied once, like number of faces divisible by 2 and number of bases divisible by 3. 2 into 3, 6. How did you get that? We did not discuss in crash course. The reason is in GATE exam also you don't need it mostly. So 2 into 3, 6, that's a compound principle only. Using compound finite automata also you can prove that. Like another proof is for L1 you can write a finite automata 1, or you can design. L2 you can design a finite automata 2, and you can do the Cartesian product, and which can prove all of them. It can prove L1 union L2. Not only union, it can prove L1 intersection L2. Just final states you have to change. It can prove even L1 minus L2. Even it can prove L2 minus L1. This many languages you have in the same machine. Just by changing final states, you can get the answer for all these types of operations. That means union, intersection, difference, you can prove that they are also regular by using the same proof. There are various proofs. So this is not required for the exam point of view, but if you learn it, if any time it comes, then you will be ready for facing, right? But I don't recommend to practice this in the crash course. It will waste your time. Like doing compound machine, all these things will take a lot of time unnecessarily. Now we need to practice examples. Okay, just practice examples like L1 is equal to pi, L2 is given as, let's say, any language L, any regular language L, let's say. Then what do you write? L1 union L2, and L1 is equal to epsilon, and L2 is equal to A star. Then what do you say? L1 union L2. We all know these points for practicing. A star and L2 is double A whole star. Both are regular. That will be regular, but which regular? That we want to find out. Now examples are given. Here example pi and L. L is we don't know anything is fine. And here all are examples. You need to know exactly what result comes out. Good. What is the first one? Can I say L? Pi union L is L. Can I say A star? That is L2. And can I say A star only? That is L1. And can I say A star? Because all union odd number of A's, you will get all. All union even number of A's, you will get all. This is even number of A's, this is odd number of A's. Union will make all, right? We know all are regular. Don't answer regular. We need exact answer from here. Okay. This is a third kind of question. Right. First kind of question, closed or not closed. Second kind of example, regular union regular. What is it? Always regular. Third is particular example. Here don't answer regular because already we know it is a regular only. But which language you can produce as an output? Okay. Now, using this knowledge, you can do a lot of different things. You can go to the outside world and you can talk about the union. Now, I don't know where I apply, but you should understand. Got my point? Now I know the knowledge of union. I know the knowledge of finite, infinite, regular, and maybe non-regular, right? Now, I may apply this operation wherever I like it. Look at the first point. Finite, assume FIN means finite language. Union, finite language. Can you answer it? I want what is the answer? Is it always finite, sometimes finite, or sometimes whatever? Regular, union, finite. Regular, union, infinite. This is one of the challenging slide. In revision, if you are able to answer such questions, that means you are in right track. Which language they have not mentioned, but type mentioned. We don't know result, is it empty language or A star or B star, that we don't know, but we know which type it is. We will know it. It's a non-regular. Go ahead. Expected gate questions. And already there are gate questions from this slide. What is given? Operands are given and operation is union. Now, you're not applying to particular domain. You are mixing all of them in the world. You're talking about that like regular, union, infinite. One operand is infinite language, other operand is regular. What could be the possible result? Okay. Right. That is delaying. Write the number and answer. With this, almost half of the subject is completed. Do you agree that? With this lecture, with this concept, we can answer all the closure properties that we have listed. Almost half of the syllabus is over in TOC, which is applicable for our GATE CS exam. Subject is so big, no doubt, but for the syllabus, as per the syllabus, almost it is half of the syllabus is done by today. Write the answers if you can understand. Good. Can I say always finite? We already did this. No need to do again. Just copy paste. Regular union finite. You can guarantee regular, always regular, no doubt. But we don't know, will it be finite or infinite? Need not be finite. May be finite, may be infinite. Regular union infinite, always you can guarantee infinite. Because one of the languages is infinite, result definitely infinite. But we don't know regular or not regular. Yes or no? See, very simple example. If I take this a pi, if I take this a power n, b power n, I can prove even not regular. Can you see that? Why I am not able to answer regular? Because I may get even not regular as a result. Because pi is a regular, a power n, b power n. I said that four languages could be sufficient to prove many examples. Okay. Always infinite, but need not be regular. Means may or may not be regular. Regular union regular, we know it. Always regular. Just now we have studied. Regular union non-regular. So what do you think? Is it regular or not regular, or sometimes regular, sometimes not regular? What do you think? So don't use the names like, here one is non-regular, so result is not regular. Don't use that words ever. Here pi is there. In just whatever the example I have taken. Can I take here a power n, b power n? Did I get a power n, b power n? But if I take a sigma star union, you take any non-regular. Result is sigma star or not? Here the a power n, b power n. Sometimes see, not regular, sometimes regular. That means you can't answer it always regular, you can't answer it always not regular. So this answer is need not be regular or need not be non-regular. Maybe regular, maybe not regular. Both are possible. Non-regular union non-regular. So again, don't think you will get not regular. These are the very different statements and you may misunderstand the statements. यहाँ पर नॉन रेगुलर, यहाँ भी नॉन रेगुलर है. रिजल्ट कभी कभी रेगुलर भी हो सकता, कभी कभी नॉट रेगुलर. यू कैन राइट लाइक दिस, either regular or not regular here, because both answers are possible, right? Here also same answer you can write, either regular or not regular or non-regular. So regular के लिए क्या example है? You can take like this, a power n, b power n union, इनकी complement लेना, वो भी not regular है, right? ये दोनों non-regular है, but L union L complement is always sigma star, right? This proves regular. And you take the same language, do the union, both are non-regulars, then result is a non-regular. Sometimes non-regular, sometimes regular. That's why non-regular union non-regular is either regular or not regular. And now you take non-regular language in the domain, apply the union, the result is not closed, because you can't prove always not regular. So when you are taking your domain is not regulars, then this operation you apply. When you're taking the domains are regular, this one. When you're taking the domain is finite languages, you apply this, right? Directly closure property I have taken here. My domain is not regulars, you think like this. Domains are regular, domain has regulars, domain has finite languages. Okay. Yes, good point. Non-regular union non-regular, either regular or not regular, but always infinite. Yes, good point. But it was not, we are not talking about finite infinite, that's why I didn't write it. Yes, because every non-regular is infinite. This is also infinite. Infinite union infinite is infinite, no doubt. Good point. And here also, regular union need not be regular, either regular or not regular, but always infinite. Answer is good. Always infinite. because one of the not regular, this non-regular is always infinite. Infinite non-regular is guaranteed infinite. Good point that was. Indeed. Can we try now infinite similarly? Sorry, intersection similarly. Operation is intersection. We are applying for regular languages only. Closed or not closed? Closed. Same compound for interpreter, you can take the help. FA1 cross FA2. Okay. And if anybody applies a regular language, intersection regular language, what is your answer? Always regular. We'll take some examples here in this slide itself. That's the reason we said closed. First example. L1 is equal to pi and L2 is equal to any arbitrary language. What happens? L1 intersection L2. L1 is equal to sigma star and L2 is equal to any arbitrary language. What happens? L1 intersection L2. Suppose L1 is A star, L2 is B star, and what will be exact result when we do intersection? Starting with A strings, intersection with starting with the B strings. What are the strings which are common? And fifth, L1 is equal to L and L2 is equal to complement of L. What happens when you do L1 union L2 and L1 intersection L2? Go ahead. And 20 no time is. Want answers? Okay, good. What is the answer? Pi intersection anything, right? Definitely pi. And sigma star intersection anything, you will get the same L, same thing. And A star intersection B star, what is the common thing? Is only epsilon is a common to both. If you take A plus B plus, you will get pi. Correct now? Because there is no common, but here star is there, you will get epsilon is there in both of them. Here is there, here is there, right? And starting with A, here starting with B, there is no common string. And when you take the L and L complement, do the union, you get a sigma star. correct? And when you do intersection, you'll get a pi. Keep that in mind. If the two languages are complement to each other, their union is everything in the world, and intersection is nothing in the world. Let me check. Chart is delaying, right? There's a problem with the YouTube. And if anybody is not like the session yet, please do that. And also, and many are watching recorded, as this time is not suitable for many people who are studying daily or daytime, right? But I see most of the rankers, they study in the night time. But are you aware? Because they don't get a sleep till the GATE exam. They always, I've seen a lot of rankers, they mainly study in the night. The reason is, could be, they get good focus in night time because of the environment is quiet and peace, no noise, and many people don't disturb while studying in the night. But some rankers, very few rankers, they do it systematically, but you will find very few who actually does in the systematically, correct? Most of rankers, I saw it, uh, they study without any timing, like they don't know when do they sleep, right? Many people say do it systematically, but that happens only for few. But once you have the aim to crack the gate, I don't think you will get the sleep also, because in your brain the most of the concepts will roam here and there, most of the subjects will have the target, and always when you get it, tired, then you will sleep, and later on you will keep on studying it. That's the reason I'm taking the class in the night, because I know the very serious people are going to study in the night, and they might need an help from me. Correct. Can we practice very interesting questions, predictable gate questions? Let's see who will answer it. Intersection is one of the important after the complement. Remember that. You seek the gate questions. If you compare a lot of operations questions, 80 to 90% the questions based on intersection and complement only. Just go and cross check all the operation related questions. Mostly will say intersection or complement. But manage the sleep properly, because without sleeping you cannot even study in the night. Remember, night is good, but sleep is very important, because you need to balance your the daily life, correct? If you don't sleep, that will impact another day. It happens to me multiple times. If you don't sleep continuously 2 days, that next 2 or 3 days will waste. Don't do that. You sleep properly and eat properly, and also balance your time well. These are the predicted questions. And those people who are continuing from the first day and study till the last day, that we have another 5 days, because uh, the patience is very important, right? The first day what you have, the last day you should have the same energy, right? Most of the people, what they do is, I'll tell you, while continuing this session, what you do normally when you start the subject, you will start with so much motivation, but after studying the one chapter or one topic, the same motivation will not be there. You might be, lacking in the concepts, or you are not able to solve a lot of problems, or you might get bored due to, you are thinking about other subjects to finish. When you are, you know focused, these things will not happen. Okay, just wait a minute and solve these problems. I'll be back. What is the answer? Answer is, first, before answering this question, let me give you the knowledge of A star, B star. I like this language. If suppose L is the language generated by this expression, what are the strings? A star, B star means A power M, B power N, right? I told the story of this already. Now, this M comma N greater than or equal to 0. Now, always think about the 4 cases. The one case is when both are 0. The other one is 0, other is greater than 0, or M greater than 0, N equals 0. The both are greater than 0. Keep this in mind. When you write star, always you need to think about 0 and non-zero. Right? यहाँ पर क्या होगा? When both are 0, what will you generate? Epsilon. When M is 0, that A power 0 and B power greater than 0, only you will get B plus. When B power 0 is there, you will get A plus. When both are greater than 0, A plus, B plus. So only 4 types of strings are there. Not 4 strings, 4 types of strings. That means epsilon, 0 symbols, only B's, only A's, and at least one A followed by at least one B's. Are you able to understand? This concept will help you to solve the problems. Now here, you know what strings are there. Epsilon, A plus, B plus, A plus, B plus. Here also similar concept. Epsilon is there, B plus is there, A plus is there, B plus, A plus. What strings are common? Epsilon, A plus B plus. This one you can write as A star plus B plus, or this epsilon you can attach with this, then A plus B star, or this epsilon you can give with the both of them, A star plus B star. Able to understand? One of the important example, and I'm predicting that in future GATE exam they might ask such questions. Next one, the intersection of these two. You already know in A star B star this is already there, right? But A plus B plus is not here. So can I assume it is L2 only? Because L2 is there inside L1 only. And here the common is A plus B plus, all the strings are there here. So can I assume L2 only? I'm not asking about regular, non-regular. There's a blunder mistake what we are doing here. I told already. I did not ask general question. Everyone? These all are regular only. The result definitely regular, right? So these common mistakes we do always. This is not a practice about regular, non-regular. This is a practice about what language you will generate when you are given 2 languages. Did I tell that in the beginning? Because it was already answered, two regular language intersection is regular, union is regular, correct? And you are doing the same mistake answering regular, regular, regular. Who knows that? Who want it, right? Is you should know how to practice it. Okay? Just understand what I'm making you to practice. I told you it is one of the important operation. And don't answer regular. It is already regular only. Answer beyond it what exact result comes out. Then let's see who will answer it. You know this already. Still, I want you to answer now. Now you need to answer generally. Finite, infinite, regular, not regular. Previously, you need exact language out. This generalized questions. These are all closure properties only. You are applying for finite, you are applying for infinite, you are applying for regular. Even I can apply for non-regular. These are easy. Now I may mix. You can mix more, but go ahead. This kind of questions you may not find here and there in textbooks and materials, and somewhere, if you look at my class notes, you will see such examples, right? Because it's not possible to teach without understanding the concepts of the language properties. Just find out what is the right answer. What you can answer? Can you answer finite? Can you answer regular? Because every finite is the regular. So I try all the answers. Infinite, intersection, infinite. We don't know what will happen. Anything can happen. Question mark means anything is possible. Finite possible, infinite possible, regular possible, not regular possible. Correct? Maybe finite, maybe infinite, maybe regular. Okay? There's nothing, you can't guarantee always. May be finite, infinite, regular, or not regular. Anything possible. Regular, intersection, regular, always regular. Correct? Non-regular, intersection, non-regular. Anyone? The 4. You take two non-regulars, do the intersection. Anything is possible. Maybe regular, not regular, or non-regular, even finite possible or infinite. So you can say anything is possible. Either regular or not regular, either finite or infinite. You can answer all such things. Finite, intersection, regular. Can you guarantee finite? Always, every finite is regular. Correct. Infinite, intersection, regular. See, infinite, I take A star. Here I take B plus. There is nothing common, right? You can get a pi. Finite language you can get. Here A star, here also A star. You can get result is infinite, regular. And here A power n, B power n, here sigma star. Result can be A power n, B power n. So anything is possible. Question mark means assume anything is possible. There's a question mark. Okay. Regular, intersection, non-regular. And if there is nothing common, you'll get a pi also. Right. Let's take regular is also possible. Pi is regular. And finite is possible. Infinite, here sigma star, here A power n, B power n. Infinite is possible and non-regular is possible. Anything is possible. Finite, intersection, anything in the world finite only. And once you get a finite, is always regular. Infinite, intersection, non-regular. And which infinite you are talking about, you don't know. Correct? Which non-regular, you don't know. Common can be possible, not possible. If not possible, result is finite. Finite, that's pi language. Pi is can be regular, finite. Okay, anything is possible. Very, very important slide. The question mark represent anything is possible. And if it is MSQ, they might have like two options. Can you see that? Which of the following is the result of the intersection of two finite languages? Option 1 finite, option 2 regular. You have to tick both. If they ask this question, which of the following is possible? Which of the following is possible? Then all of them you have to tick, because possible only, right? They're not asking always true. Okay. Same statement you can ask different ways. Done. Another important operation is complement. Complement, is it closed or not closed for regulars? Closed, right? What is the proof? Closed for regular languages. The proof is very simple. If L is regular, we did in the class already. What we do? We design DFA and interchange finals and non-finals. You will get a modified DFA. It is another DFA. And this accepts L complement. That means we have proved that L complement is regular. When L is regular, L complement is regular. And not only this, even this direction also same. If L complement is regular, you can design a DFA and understand both the sides. It is possible. Interchange final, non-final, you can get modified DFA here, and that is definitely L. So if L is regular, L complement is regular, L complement is regular, L is regular. Are you able to understand? Infinite is also, but we're not talking about non-regular, right? Infinite language and regular will always have a DFA. Same proof exists. If it is only infinite and that is not regular, we can't prove it. We are only talking about regular languages. Okay. So this statement will prove 2 points. L is regular if and only if, wait, L complement is regular. Second point, L is, if any one of them you got a not regular, then other is also not regular, because if any one of them is not having DFA, you can't do these things, right? If any one of them you see non-regular, then other definitely not regular only. That's why, if you remembered, I have given some examples. L is equal to A power and B power, and I say not regular. Even complement also I say non-regular because of this fact. Both are not regular only. Done? Yes, Besant Tommy. The proof is here. Why complement of regular is regular? It is mostly interview question when you go for ISRO, BARC, DRDO or something like that. Even IITs. Complement operation may be asked in interviews. Let's try some examples. L is equal to pi. What do you say complement? Don't say regular, I know, but I want an answer from you. Exactly what language you can write. L is equal to sigma star. What is the L complement? If L is equal to epsilon, then what is L complement? If L is equal to sigma plus, what is the complement? Without knowing the language, you can write in general using pi sigma star concept. I'm giving the hint directly. If you know the hint, the answer is over. You know the definition, right? L complement means sigma star minus L. This definition you have to use at any cost. The sigma is A comma B, then you have to write A plus B whole star. If the sigma is A, you should write A star. Sigma is A comma B comma C, then you should write A plus B plus C whole star. So sigma will change, then answer will change. Here my assumption, all of them sigma can be A comma B because those symbols only I have written. Okay, the first four are in general. Any sigma, these are applicable. What is the answer? Without knowing what is your sigma, you can write an answer sigma star. Whatever is sigma, the sigma star always answer. Here pi, here sigma plus, here only epsilon. So these two are complement to each other, these two are complement to each other. Now A star B star over the sigma A comma B, then its complement will be here, right? Fifth complement is 6, sixth complement is 5th. So this is a sigma star B A sigma star. And here is the A star B star. Here the 6th and here is the 5th. Both are complement to each other. And these two are complement to each other. Now here, starting with a complement, what are the strings we'll have? Outside epsilon and starting with B, correct? And starting with B complement, outside epsilon and starting with A. So understand the 7 and 8, which are two different examples. Okay. So these three operations are very, very important for all the chapters. एंड याद रखना जो यूनियन, इंटरसेक्शन, कॉम्प्लीमेंट सबके लिए इंपॉर्टेंट है. फाइनाइट लैंग्वेजेस, इनफाइनाइट लैंग्वेजेस, रेगुलर्स, नॉन रेगुलर्स, DCFLs, CFLs, and decidable languages, and in future RELs. All the languages, these three operations are very important. Okay, you should not ignore understanding examples, understanding the proofs if possible. Okay, remaining proofs may not be required. Difference you can prove using L1 minus L2. You can prove intersection and complement. We know these two are already closed, so difference is closed, correct? And symmetric difference, you know, right? If there are two languages, this portion is called as L1 minus L2, right? Because only L1 we call L1 minus L2. Symmetric difference, there is L1, you may use delta, or you may use some textbooks, you will use exclusive or something, and L1 union L2. From this you delete the common portion. It's nothing but if there are two languages and if this is L1, this is L2, only L1, that's L1 minus L2, and only L2 we call L1 symmetric difference with L2. This can be written another way, which is L1 minus L2, this portion, and this portion is union with L2 minus L1. There is another way to write the same concept. Okay, तो आपको पता है यूनियन इज क्लोज्ड, डिफरेंस इज क्लोज्ड, इंटरसेक्शन इज क्लोज्ड, so definitely this operation is also closed. Likewise, you can make your own operation. Like I want to make my own operation L1 L2 is equal to L1 complement intersection L2 star. Oh, star is not discussed yet, right? L2 complement. Then if intersection complement are closed, this operation also closed, right? This is how you can prove the new operation. Even somebody want union with something else, then try to understand union, complementation are closed, then this operation is also closed. Got it what I am trying to say? And sometimes you may apply for even more operands. Like you want to apply some new operation of L1 comma L2 comma L3, which is equal to L1 union L2 intersection L3 complement. Then this is a new thing, right? So union is closed for regulars, intersection is closed, complement is closed. So this new operation is also closed. This is a ternary operator. So likewise, you can invent the new operators in the world and you can apply here. Concatenation, you can use a regular expression to prove. It is closed for regular. I'm not writing now. So if anybody says regular language dot regular language, you will always get regular only. Dot is already an operator in the expression, so you have proved without any example. We'll directly practice example. L1 is equal to pi and L2 is any regular language or any language in the world. L1 dot L2. What is your answer? L1 is equal to, let's say, epsilon, and L2 is any language in the world. L1 dot L2. L1 is equal to A star and L2 is equal to B star, and L1 dot L2, L2 dot L1. Here L2 dot L1 I am not writing because that will also give you the same answer. The first two. Third one you will get a different one. क्या है answer? So similarly, can you do for the remaining operations? Because I see 2 hours is done, and can you work on the remaining operations on your own? In exam, if they ask example, you should know the definition of each operation. Okay. A star, B star, C star, A star. Do you want me to complete all the operations, or will you do on your own? Is your choice. Because another 2 hours is there to spend. If you want to work on your own, then it's fine. Already I have listed operation names. And for each operation, I'll give one example to understand. This concatenation should follow the order. True. The another operation, what is it after concatenation? Reversal. Reversal has a lot of important points. It is also closed for regulars. I no need to write this word, correct? You know which are not closed, which are closed. And if anybody takes regular language and they do reversal, what do you get? Always you will get a regular. What is the proof? You can take the regular expression, write in reverse, or design it finite beta. You can also make all the edges reverse from final to initial and make interchange initial final. You can do various algorithms are there. And now we'll take examples for each one. Proof I'm leaving to you. And let's practice. Suppose L power reverse of reverse, if you do, what do you get? Second, if you take L is equal pi and if you do reverse, what is your answer? L is equal sigma star, do the reverse, what do you get? In exam they may ask any such points. Let's say you have a starting with A and assume sigma is equal to A comma B or A whatever. What will you get? The reverse. And fifth, L is equal to A star B star. What is your reverse language? You should know what do you mean by reverse, right? Every string will be reversed in the language, so that language will be reversed. Reverse is also same. A reverse is ends with A. It starts with A, here ends with A. Here A is followed by B, here B is followed by S. Okay. Remaining closure properties, please practice them in case if you want to learn each one. Otherwise, you already have a shortcut. So learn union, intersection, complement without doing any mistake. If you want, directly I'll shift to the last finite union and infinite union. Two examples I'll explain so that you can apply for the remaining two. Finite union is nothing but you are doing the finite number of regular languages. How many regular languages are there? There are k regular languages. You can also say this is a k array operator. K inputs are there. K should be greater than or equal to, because it should be binary, ternary, or any way you can apply, because at least two languages should be there to apply this finite union. Okay? The result you can always prove regular, because we have an algorithm for single union. Yes or no? First you will apply L1 union L2. You got a regular. And apply with L3. You got a regular. Because you have the algorithm to apply the two regular languages. And similarly, you are applying till LK. Did I prove that? K minus 1 times you are going to apply the algorithm that is there for the union. Please attend सत्यजीत. अगर आपको अनडिसरेबिलिटी कॉन्सेप्ट चाहिए, लास्ट 2 डेज अटेंड करना. आज 5th डे है. 6th 7th 8th के बाद 9th and 10th अटेंड करना. 2 क्लासेस इंपॉर्टेंट है आपके लिए, ठीक. बट उससे पहले सारे 8 क्लासेस इंपैक्ट करेगा 9th and 10th. जिसको अनडिसरेबिलिटी डिसेबिलिटी की चैप्टर चाहिए, तो उससे पहले जितने भी चैप्टर्स है सब समझना चाहिए. आप बिना समझ के जाओगे तो वही बताता, कुछ टॉपिक्स आपको पूरा सब्जेक्ट को डिसाइड करता है, राइट. इफ यू डोंट अंडरस्टैंड द सब्जेक्ट, यू डोंट अंडरस्टैंड सम टॉपिक्स, स्पेशली डिसेबिलिटी एंड डिसेबिलिटी. वो 2 टॉपिक बताएगा, आपको पूरा सब्जेक्ट समझ में आया नहीं आया. ऑफकोर्स कुछ कॉन्सेप्ट्स इजी है, बट ऐसे वाले कॉन्सेप्ट्स को थोड़ा टाइम लेके पढ़ना होता है. Finite union, everybody understood why it is closed for regulars. Union of finite number of regular languages. Here k is finite, so k can be 2, k can be 3, but k should be a constant. You can take 100 regular languages also. Okay. Day after tomorrow is the PDA. Tomorrow is the context-free grammar. Now, infinite union. How do you apply infinite union? There is infinite array operator. So infinite inputs are there. You are doing union how many times? Even you don't know how many times. There's, of course, you know it, infinite number of times you are applying it. And this is practically impossible to do, correct? All are regular, but result you may get either regular or not regular. You have to prove it with examples at least. If I take L1 is sigma star, 2 doesn't matter how many times, infinite times also. Result is sigma star. So we got regular is possible, correct? And not regular, if I take epsilon here, my L2 is AB and L3 is A square B square. I will only take this form. And L4 is A power 3 B power 3. And so on. If I take them, you will get A power n B power n language only, because you are doing infinite time. So sometimes regular, sometimes not regular. When you do infinite number of regular languages union. That's why this is not closed. Why we say this is not closed? The reason is here. Understood this point? Similarly, you can think about all the infinite operations like infinite, intersection, difference, concatenation. Okay, जो operations इस सेशन में डिस्कस नहीं किया, अगर आप interested हो so you can find out the reasons, definitions. In case if you want me to explain, you can also ask me anytime which operations you want me to discuss in the class itself. So can we wind up today? So today I'm not discussing the finite automata questions. Okay, I'm giving you the a pumping lemma definition. If anybody want to learn a pumping lemma definition, so remember this pumping lemma is true for regular languages. Any regular language you can prove using pumping lemma, but this proof is also you can use for non-regular using contradiction. So this is without contradiction, and for non-regular with contradiction. So before that, what is pumping lemma? Pumping lemma. Remember, you can use two ways. One is to prove, because the pumping lemma for regulars, it is designed to prove regulars. And this pumping lemma, if you give regular, it will give you a proof why it is regular. What is the proof that we are going to learn? Okay. And you can use another proof, pumping lemma, that is using contradiction. It's very famous. You give not regular, it will prove for not regular also why it is not regular. So pumping lemma you can use for regulars because it's designed for regular, but that will also help you for non-regular using contradiction principle, right? And few points that will help you to answer theoretical questions. Pumping lemma always satisfies regular languages because designed for regular languages. Pumping lemma can be used to prove non-regulars or non-regular using contradiction. Direct proof we use for regular, contradiction proof we use for non-regular. And remember this point, pumping lemma cannot help you to identify unknown languages, identify arbitrary language, whether it is regular or not regular. It will not help you if you don't know it. If you know already regular, you can prove it. If you know already not regular, you can prove it. But if you don't know what language it is, pumping lemma will not help you. So what is this proof for regular languages? If A is regular, remember that if A is regular, then there is a number P. Remember this was the GATE question which is asked in GATE and may come in future again, where W is any string in A, that's W belongs to A, that's the meaning. W belongs to A. Of length at least to P, that means it should be greater than or equal to P length. The length of the W should be greater than or equal to P. So they asked which of the following is the P or the pumping length. W may be divided into three pieces, that's W is equal to XYZ, and the rules are that middle portion should be greater than 0, that means Y not equal to epsilon, and the XY length should be the less than or equal to whatever the P that you assume. And for each I greater than or equal to 0, you have to prove X, Y power IZ belongs to L. It means the W is divided into three parts, X, Y, Z, and this Y will be pumped 0 or more times. And every time you do this repetition of Y, then the result has to be belongs to L. So for all I greater than or equal to 0, the xy power I, the y you are repeating, every time it should be belongs to L if and only if L is regular. Already L is regular, we know it. So what is the point they ask? The W, right? W belongs to A. The length of the W greater than or equal to P, then what is this P? How do you find this P? How do you find? This is the GATE question. And then I'm going to explain. First, remember the definition. What is the pumping lemma proof? For every regular language, there is a P. What is that P we are going to learn? Where you can take any string in the language that string length should be greater than or equal to P. Less than or equal to P, we should not take. That string always have somewhere the pumping, that is Y, can be repeated to get the whole string is in the language itself. So this is the concept given, and the middle portion which you are repeating should not be epsilon, and the length of xy should not go beyond the P that you assume. So now if I take, let's say L is equal to ABB, starting with ABB, you can see you can take a minimum DFA or minimum NFA, both can give you the P answer. And if I design any finite automata which is minimum, I'm taking NFA to prove it. And look at this. I have the 4 states, right? I have 4 states in a minimum finite automata. NFA or DFA you can take. Okay, I have taken NFA. Now the P should be greater than or equal to 4. You can assume P is 4. We can prove. We can assume. Or we can take P is equal to 5. You can prove, you can apply. There are infinite pumping lemma proofs for the same language, because a different piece you can choose. And every P you choose, and for every W which is in A and its length is greater than or equal to P, you can always prove it. Understand the proof? And P, you can choose any value. So they may ask you, which of the following can be P? They will give option A 2, B 3, C 4, D 10. So D and C you can choose, but 2 and 3 should not, because if you choose P is 2, every W which is greater than or equal to, you can't prove it. If C, to get the cycle, you should take more than 3 length. If you take 3 length, that ABB will not have any the cycle or self loop, because that cannot have the Y to repeat. And if I take the B is Y, and if this is 0, then AB may not be in your language. There's a problem with the repetition. If you want to have the infiniteness, there should be somewhere self loop or cycle should be there. That happens when you take more than 3 length. So if I have 4 states, my string has to be 4 or more. If I take a 4 length string, see A, B, B, you must take a cycle only. So without that cycle, impossible to understand more than 3 length. If you take more than 3 length, definitely, because you have 4 states, right? Definitely somewhere cycle will happen. Yes or no? If I take 3 length, I can't guarantee. If I take 2 length, I can't guarantee cycle will happen or loop will happen. If I take 1 length, I can't. So my string should be more than 3 length, that is minimum 4 length, to have a loop inside this machine, right? And finite languages we no need to prove, because anyone, finite languages you can't prove it. The reason is you can't find the P first. Okay, a string first, string. This is how you prove. There are so many proofs for the same problem, okay, based on the P that you choose it. This is a kind of GATE question that you will see. And another GATE question in future, it may happen. They might be giving you proof and find out the missing statement. If they miss this statement, you should answer it x, y power I, z belongs to given language. Okay. Or they might miss any of this condition in future GATE questions. So I'm leaving to you right now. We'll solve these questions later on, and finite questions still pending, right? We'll do some other day whenever we complete the class early. Can we wind up again today early? Because I can see very less students are there. When we have more students in the class, we will do this problem practice. If you have any other doubt, आज नॉन रेगुलर का वैसे भी प्रूव करना जरूरत ही नहीं है. इन केस यू वांट टू प्रूव इट, यू कैन डू इट. सेमेस्टर के लिए तो प्रूफ चाहिए होता, बट गेट एग्जाम के लिए जरूरत नहीं है. The last class, some of the students asked like how to face the test series, right? Anybody not there in the last class, please watch the video at the end of the session. I'll take the class till you complete the TOC, right? क्लोजर प्रॉपर्टीज कंप्लीट किया हम. अगर कंप्लीट नहीं हुआ तो विल टेक टुमारो आल्सो सेम टॉपिक. Tomorrow Sunday will also be there. Tomorrow topic is, I think, context free grammars. The more interesting again, like regular grammars. Cricket is already scheduled, I guess. Tomorrow class, is it not scheduled? Oh, is it not scheduled? Okay, will be scheduled. Thank you all. Because when the important topic is there, we'll take for 4 hours every day, and there is a topic which conclusion is there, then we can wind up early. Like today and yesterday, we had conclusions of regular languages, right? But again, PDA, DPDA comes, you need more time to practice. So there you will spend a lot of time. Tomorrow again, we'll have less time. And day after tomorrow again, very important for the construction. Maybe tomorrow I'll start if I wanted to. बट टाइम को यूटिलाइज करना, मैं 4 घंटे भी ले सकता हूँ, बट मुझे पता है क्रैश कोर्स में जितना चाहिए उतना ही पढ़ाना है. अगर पूरा सब्जेक्ट को पढ़ाना है, इस 4 घंटे में टॉपिक ही कंप्लीट होता. मैं ये नहीं कर रहा हूँ आपको 4 घंटे बैठा के और टाइम वेस्ट नहीं करा रहा हूँ. जितना आपको गेट के लिए चाहिए वही आपको कवर कर रहा हूँ. अगर कोई भी टॉपिक आपको दिक्कत करेगा, थोड़ा टाइम स्पेंड करना, काफ़ी क्लियर होगा कि काफ़ी टाइम है आपके लिए बचा है. शर्मा, अगर किसी को भी कनेक्ट में गाइडेंस चाहिए, यू कैन ज्वाइन और कनेक्ट ऑन GFG, and you can drop a WhatsApp message or let me know on Telegram. We'll be having discussion for your preparation. Now you can practice all the GATE PYQs for regular languages except the finite with output, more and milli motions, right? At the end we can cover those 2 topics also. Please do practice now. First chapter, at least 80 to 90% of the questions you can solve in single scan. That may take time, some of the questions, based on your practice. I'll be sharing the file in this drive link.